Welcome to this video on Houdini rendering. Today we're going to be discussing several topics. We're going to start with ROPs, which are render operators. Those are the output nodes that define what we render and how we render, what render engine we use, and a whole bunch of other information. We're going to talk about bundles, which is a form of group. You can have groups of lights or objects or whatever and assign them to different ROPs in different ways. We're going to talk about takes, which are like render layers. Kind of like render layers on steroids, actually, because you can do a lot more than create render layers with them. And we're going to talk about render dependencies, which has to do with how we link together ROPs to render certain things before other things. For example, if you required photon maps to be generated before a final render, you could link two ROPs together, and the first one would create the photon map, and the second one would use it. So without further ado, let's get going. Okay, in this first section we're going to take a look at ROPs. So first we need to go to our outputs. Right now we're in objects, so we'll simply go over to out and we'll lay down a matcher node. We do this simply by typing tab, going to render and picking matcha, or we can click tab and type MA and it'll filter it down for us. So there's Manta right there. I'll just drop one down. Here's the interface. We'll embiggen it a little bit so that we can take a look at what's inside that interface. Okay, to begin with, we have the render button. We can render with this ROP right now simply by hitting the render button. And the image will go wherever it says in properties. Right now, the output picture is sent to the image preview, which means it'll render in a window right in front of us. Or we can simply set an output directory here for this as well. Here's where we set our frame range. We can render any individual frame, which is normally what you do when you're doing test renders. You go to frame, set up your lights, hit the render button, and you can either click render here, or you can actually go over here and render on your Mantra 1 node as well. It's the same thing, and we'll get a render out of that. So there comes our render, and this is the image preview. It's rendering out to mplay, and that's the typical image preview for Mantra. Okay, so if we don't want to just render any arbitrary frame, we can set a specific frame range, whatever to whatever, by however, so we can render every single frame or every second frame or whatever. We can render with a take if we've set one up, and we'll be looking at takes a little bit long. Currently there's only one take, the main. And then we have these tabs down here. The main tab allows us to define what version of Mantra we're going to render with. If you click on it, you can see there's different versions, so you can, if you have older scenes and you sometimes want to keep those legacy renders in there. You decide which camera you're going to use for this ROP. So if you have a number of cameras, you can pick from the ROP which camera is going to be involved in this render. This section command defines where the IFD is sent. IFD stands for instantaneous file descriptor. It's like a RIB file for RenderMan. And if you're not using a command and you decide to put the IFD file to disk somewhere, then that command is disabled. So you can define where the IFD is going to reside on disk as well. Under the Objects tab, we get to pick which objects and lights are going to be used in the render. And star, of course, means everything, or we can type in the names of individual objects, or we can select them from a list, which is probably the easiest way to go about it. So for example, we might open this up and currently all objects are selected. What if we only want to render the ailerons? We can just control click or shift click to select the ones that we want. And we go accept pattern, and now those object names will be in here and all the other objects will be excluded from the render. Let me try a different pattern. Let me try just the fuselage and the tires, and we'll leave everything else. And then we'll take a look and see what that render looks like. So you can see how that worked. It excluded everything else from the render. Alright, it's rendering the whole frame sequence right now because we set a frame range. So I'll interrupt that and I'll set this back to render any frame. I'll set that back to everything just by putting an asterisk in. You can force certain objects to render. Again, the same thing, you put their pattern in. You can force matte objects, you can force phantom objects, and you can force exclusion of objects. All in exactly the same way. It's actually very straightforward. And then you can do exactly the same thing with lights. Solo lights, so you can pick only a single light. Right now, candidate lights is everything. There are no actual lights in the scene, so it's just using the headlight. And also, you may wish to turn the headlight off, and you do that here as well. Simply, here's the headlight creation button. It's considered all light, so it's here with the lights in the Objects tab. And you can also force lights to be used in the render, no matter what they're. And the purpose of force is that no matter what the object's status is, it is forced to be used in the render, whether it's off or phantom or whatever. Exclude, we'll be sure to exclude them. Properties is a more complex tab. This is where we get into a lot of technical detail about the properties and quality of renders. Once again, we looked at, well, for example, we look at here where the output picture goes to. Right now it's going to the image preview. And you can set a path for the picture to be saved. Under normal rendering situations where you're rendering an image sequence, you would set this to a file path. And then there's various other filtering settings and so forth down here. In the second output tab, there's a lot of additional information. You can set quality levels, compression levels, and so forth. In the render tab, this is where things start to get a little bit interesting. Here's where we select our rendering engine. If this were me setting this up, the render tab would be right out front. It would be the first thing because it's usually the thing we're most interested in right away. By default, it's set to micropolygon rendering. There are 5 options in here. Micropolygon, ray tracing, micropolygon / PBR, physically based rendering. Then there's straight PBR, and then there's photon map generation. It's been quite common to use micropolygon only in the past. It's a very efficient rendering method. Personally, I love using PBR. I get by far the best image quality out of PBR the most quickly, so that's my personal preference. There's also a whole bunch of optimizing in here. Tile size refers to the size of each bucket as it renders. If you don't want to use all the processors, say you have 8 procs in your machine and you want to do something in the background while you're working, you might set this to 7, so one processor remains free. There's various other esoteric settings in here. That will be the topic of a more advanced video. Sampling is where we can enable depth of field and motion blur, set the settings for motion blur, for example, and the style of motion blur. Pixel samples is very important. If you're finding your image kind of chunky, definitely you want to increase your pixel samples, and increase your max ray samples as well. You want to reduce your noise level if you have too much noise. Usually good production quality noise is going to be 0.03 or sometimes as low as 0.01 if you have very flat, very simply textured surfaces. In the shading tab, reflect limit and refract limit, that means the number of times that a reflection will occur, the number of times that a refraction will occur. For example, if you have 2 mirrors facing each other, they reflect, I don't know, a zillion times. We're limiting it to 10 here by default, so that we don't suck up all our render power doing infinite reflections that you may not necessarily see. If you're trying to do really quick renders to begin with, you're not that interested in quality yet, you can set these down to very comfortably down to 3. And as a matter of fact, I would probably do that by default, and I wouldn't increase them unless I really needed to. And you know when you need to increase your reflect limit because you see funny black areas in the middle of your renders where reflection should be but is missing. Diffuse limit is used to define the number of diffuse light bounces. So if you're using PBR, for example, you need to turn the diffuse limit up to get some really nice beautiful light bouncing happening in your scene. If you're just learning Houdini and you want to know any more information about any of these, it's pretty easy to sort out. For example, diffuse limit. If you just hover over the name for a moment, you'll get this description. Diffuse limit, limit the number of diffuse bounces. Diffuse bounces usually contribute to the majority of global illumination in a scene. So increasing the diffuse limit will produce more accurate global illumination. And then if you want more information, you press the F1 button, you'll get a floating help, and it'll give you more detailed information. So, we're going through these kind of quickly. This is an introductory video, and if you want more deep information, there's a lot of really esoteric parameters in here. By all means, go ahead. We're just doing an overview here. So, volume limit refers to doing volume bounces in PBR. The ray tracing bias, if you're familiar with mental ray, you know what ray tracing bias is. The higher the bias, the more the shadows are going to stand away from your object. So usually a lower ray tracing bias is a good thing, but it's more expensive. You want to go as high as you can without starting to see cracks in corners and so forth. You can pick what color space you're going to use here. Gamma 2.2 is something like sRGB color space. And then linear is linear. If you're not familiar with a linear and sRGB color space, then you probably should become familiar with it. It's a big deal in the industry these days. We're going to look at that in another video, but we're not covering that here. Alright, in the PBR Render tab, we have the option to use a specific PBR shader. Now, this was originally introduced when PBR came into being, and there were no shaders, or a few shaders written that would work with PBR. The old shaders didn't work with PBR, so you had to have a specific PBR shader involved here. These days, the Mantra Surface shader is fully PBR compliant. You don't have to worry about it. You can generally leave this blank, and the only time this has to be specifically used is if somebody has, a shader writer has gone and noodled around with the PBR algorithm, and then they need a special shader for it. And it's the same thing with this PBR photon shader. Once again, you don't need to put anything in there unless some shader writer has noodled around, in which case you'd put your special shader in here. Here's another fairly esoteric setting: allowable paths, the type of path tracing to perform in PBR. Now this is a little bit typical of some of the help you're going to get. Some of it is so it kind of says some words, but you read them and you don't really understand what they are. So this is a good time to go onto Oddforce or the side effects forum. If you need to know this information or simply want to know to become a more skilled Houdini artist, and just find out. Or you can go to the F1 help and find out some more information. Color limit has to do with rendering in high dynamic range. Often we render far above RGB color space these days, and one of the reasons for that is that real light exists far above simple sRGB color space. And sometimes we might get really huge spikes in our renders, especially if we're lighting with HDR images that can have extremely high values, especially if, for example, there's a sun in the image. And what this does is this allows us to clamp the upper value so that we don't get these very bright spikes in our renders. The minimum reflection ratio is it's kind of like a reflection quality setting. If you find that your secondary reflections are becoming noisy, you can turn this up a little bit. You could get a little bit better quality. Stats. Okay, verbose level refers to the reporting back that the renderer does while it's rendering. If you want to diagnose your render, turn this up and you'll get more and more information as you turn it higher and higher. If you want the renderer to report out the way Alfred does, you can do this, and Alfred is part of Pixar's RenderMan. It's the render manager for Pixar's RenderMan. Something called a Python tile callback, which will mean very little to artists. What it's saying is that the image is rendered in tiles, and after every single tile that's rendered, a Python script can be run to for example, query the data and find out information about it or whatever. Again, this is probably a fairly pipeline-y type of feature that's in the ROP. It's excellent for large studios, and if you're working by yourself in Houdini, and especially if you're not a Python coder, probably not necessarily something that you need to spend much time looking at. Here we have a couple of quality multipliers, a shading quality multiplier and the ray shading quality multiplier. They're both quality multipliers. One is used for ray tracing and the other isn't. You'll notice this one is grayed out. It's because currently the render we're using, I think it's set to PBR. Yeah, physically based rendering. If we switch it back to micro polygon rendering, we'll see that now the shading quality multiplier is available. It's a global quality multiplier, and as you turn it up, of course, the shading quality is going to improve. And if you're ray tracing, you can have a separate quality multiplier for ray tracing. And the remainder of these settings have to do with looking at polygons to see if they're too big to render and chopping them up into little bits and measuring them to see if they'll fit and so forth. Is fairly esoteric and generally important for really huge scenes. In here, we have the option to, if we want to diagnose our IFD, we turn off, say, binary geometry, and it'll turn into ASCII so we can read it. It's obviously a lot larger and less efficient. So normally we want to leave this on, save our geometry in binary. And then saving geometry groups, you can save your geometry groups. The problem is they'll be saved in the IFD. It'll increase the file size. It'll take a lot longer to render your IFDs. So normally we leave this off by default. Here is one of my favorite tabs as a lighting artist, Enable Irradiance Cache. What this does is this allows us to record the irradiance as it's generated in a render and cache it to a file. And once we've cached it to a file, we can read it like we would set it to write to create the irradiance cache. And then when we're done, we would set it to read, and we can put it in a file location. And once we're reading it, we're no longer calculating the irradiance, and that's going to, it could, depending on the complexity of the scene, could massively improve our render time. So I love this. This is one of my favorite things. So the last tab in the ROP is the scripts, and once again, this is for Python coders, or I guess HScript coders. You can do either, and you can run a script before the render. You can run a script before each frame. You can run one after each frame, and you can run one after the render is completed. And there's tons of reasons why you might want to do this. For example, a post-render script might be a script that will go through and check to make sure that all the frames are rendered, and if certain ones aren't, record what they are, and then go back to the render farm and requeue them so that you don't have to come in the morning and find 8 failed frames among your 240 frame long render or whatever. So that's what these are good for. Automating your render process and adding extra mundane tasks that are simply repetitive anyways. So that concludes our general overview of a typical Mantra ROP. In this section, we're going to take a look at takes. You can think of takes as render passes, but they're a lot more than that. What a take really is, and if we look over here on our take list, what a take is a version of all the nodes that are currently in the scene and their parameters. And in any individual take, you can change any parameters in any nodes that exist in the scene. So all a take is a different set of parameters for nodes that already exist in the scene. Takes will not add or subtract nodes from the scene. They will only record different sets of parameters within those nodes. Now, since there are a lot more nodes than simply materials and geometry nodes, you can use takes for a lot more than just render passes. But their original concept was to use them as render passes, and the developers at Side Effects realized they'd be useful for all kinds of other things. So instead of calling them render passes, they gave them a more generic name, and that's why they've called them takes. So before we actually get into creating some takes, let's just familiarize ourselves with our scene. What we have here is this biplane. I'm just going to move the camera back a little bit. I'm in the camera view, so I'm going to lock it, and I'm just going to push back a little ways. And what I have here is a grid on the ground and this little biplane, and the biplane is composed of a whole bunch of parts. Let's take a look at all those parts. So we have the fuselage. I've color-coded the fuselage in the middle just so it's easy for me to find. And it's the parent of all the other objects, all the other geometry pieces. There's wings, ailerons, propeller, lower ailerons, windscreen frames, struts, gear legs, fairings, cockpit coaming, tires, wheel hubs, rear wheel axle, elevator, rudder. And then we also have the grid, which is on the ground, which I've also color coded. I like to color code the ground brown. That just reminds me of dirt. And a camera. And I generally color code my cameras black just because it's a easy visual for me to remember my cameras. Now, there's no lights in the scene yet, so when we go to our render view, it's simply going to render with the headlight. And the headlight is the default lighting that exists in any Houdini scene that doesn't have other lights in it. Now we're not going to want the headlight, and the headlight will disable itself as soon as we put a light in, but it's useful sometimes to know where you can turn the headlight off. And the headlight can be turned off in the ROP, the render operator. In this case, the ROP is right here. It's out mantra 1. So go to our outputs, find the mantra 1 node. There it is. It's the only one in there right now. Go to the Objects tab, and if we scroll down, we see headlight creation. If we turn that off, the scene should render completely black because now there are no lights and there's no default lighting in there. We'll leave it on for now just so we can see our way around, and we'll notice that as soon as we put a light into the scene, that the headlight will just disappear. It'll stop working. So let's put some lighting in the scene. I think I want to make this feel like a sunny day. So I'm going to want some kind of a sky, and I'm going to want some kind of a sun, which are the two primary light sources that you're going to find on a sunny day. Other light sources could be light bouncing off of nearby buildings, especially if they're light or brightly colored. But in this case, we'll just call this a flat ground plane, which we may give a little bit of texture to later. But we're going to put in a sky and a sun. So two light sources. So I'm going to add, for my sky, I'm going to add an environment light. There's my environment light. And it's popped in way down there. I'll just move it up closer to the rest of the nodes. And I want to give my environment light a color code. Now, I normally color code my lights yellow if they're, like, for example, incandescent light sources. But the skylight is blue. So first of all, I should name it skylight. And I'm going to color code it blue to remind me that that's what it is. So I just click on this little color swatch here, and I can just pick any of these colors. And the node turns to whatever color I want it to be. Now let's have a look at a render with the skylight in. We can see that the headlight is no longer working, and we see we're getting the kind of look we're getting. It looks like an overcast, cloudy day, and that's definitely in the right direction of a skylight. What's stopping this from looking like a skylight? Well, there's two main things. One is it's not colored. One of the reasons it feels like a cloudy, overcast day is because the light coming out of the bottom of clouds is usually pretty gray, and the light shining down here feels pretty gray. In order for it to feel like skylight, it needs to feel kind of blue. So let's pick a light color that is in the range of sky blue. It's going to be something around, something down here. It's pretty subtle blue. Now it still doesn't feel like skylight. One of the main reasons is that the sky back here is all black. So it feels really wrong. We really need to see that beautiful sky blue color in the backdrop in the negative space in order for this to start feeling like a sunny day. And we can do that with our environment light. We can tell Mantra to render the actual light itself by clicking on this button, Render Light Geometry. When we click that on, we'll see that now we have this beautiful sky in the background. It's the color of the light. And because it's an environment light, it's infinitely distant. So it's just this big, spherical, infinitely distant light source. Now, typically, the sky dome only comes from above. So we can do that. There's another very handy little switch right here, clip to positive Y hemisphere. And what that means is it'll emit light only from the horizon and upward. And it doesn't make much visual difference here because we already have a ground plane below that's blocking out any light that might be coming from below. But in the case where, for example, this aircraft might have been off the ground a ways, you would definitely see a difference. So what's missing here now is direct sunlight. Now if we look up on the shelf, we see a number of lights. They're not all here. But the closest one to sunlight that's in the shelf is the distant light. So let's start with that. So I'll just drop it into the scene here. And that's what it looks like in the scene. But I don't actually want to use a distant light. First I'm going to turn it towards my aircraft. I don't much like the distant light. And the reason is, as you can tell by the gizmo here, is that all the rays are perfectly parallel. And in sunlight's case, while the rays of sunlight that reach the planet Earth are pretty close to parallel, they're not perfectly parallel. And let me show you what it looks like. When the rays are perfectly parallel, you can see that the shadows are 100% sharp all the way around. And as this image resolves, you'll see them really sharpen up. And that may be okay for less than photoreal results if that's what you're after. But if you're looking for really photorealistic lighting, and you're a lighting artist and you've studied lighting and shadow pretty closely, you've noticed that shadows are always sharp where the object casting the shadow touches the object receiving the shadow, in this case the ground. And that as the shadow gets further and further away from the object that's casting it, they become softer. This is the penumbra of the light becoming visible. And in order for that to happen, there has to be some angle to the light. And the distant light isn't equipped to do that. If you actually look in the distant light options, you can see there is something called sun angle, but it's grayed out. And the reason is because this light type doesn't support that control. In order to use that control, we need to switch to a sunlight. Now a sunlight is a lot like the distant light. The main difference is that it has a sun angle. The sun angle is by default 5 degrees. If you look at the shadows, you can see that they've softened up quite a bit. And we're just going to take a moment and let this shadow resolve so you can see that it's sharp right where the tire touches the ground, and it becomes softer further and further away. Actually, one way I can really speed that up is I can do a render region inside my IPR simply by holding down the shift and creating my region and letting go. If I want to turn that off, I just shift click outside of the IPR, but I do want it to be there, so I'll just add that right there now. Just let it resolve for a moment. So you can actually see now that the shadow is really quite sharp right here by the tire, and it very quickly falls off into this softness. Now, this really doesn't quite look like sunlight, does it? And the reason for that is that the default angle for the sunlight is too broad. 5 degrees is too big. Imagine looking up into the sky and imagine what 5 degrees is and how big that sun would have to be to cover 5 degrees of the sky. It'd have to be enormous. We'd probably be incinerated here on Earth. I've experimented with the sun angle, and I've found that a reasonable imitation of actual sunlight is around 1 degree. So when I set that to 1 degree, You can see the shadows sharpen up quite a bit. They're still going to be a little bit soft with distance. And you'll notice if you look closely at shadows from sunlight that it does take quite a lot of distance for the shadows to start softening up. And you'll see it most prominently in shadows cast from very tall trees or tall buildings or telephone poles or something. But items that are close to the ground will cast shadows. You won't notice the softness quite so readily. You'll have to look for it, but you'll see it for sure. You'll see even with a small item, if the shadow's long enough, that out towards the tip of the shadow, it's not completely sharp. That's just not natural. Real shadows aren't like that at all. So this is actually starting to turn into a bit of a lighting lecture, and we need to get into takes and ROPs. So I'm just going to make an adjustment to the sunlight and move on. Now the sunlight, by default, is white, and I should actually rename this node sun, and I'm going to color code it yellow, and I'm going to move it up where everything else is. And by the way, if you don't already know, the way to get everything into screen is to simply type H. And I think of that as homing on everything. So our sunlight is white, and sunlight coming from the sun, when it reaches Earth, by the time it reaches the ground, is not white, it's amber. It's had a bunch of the blue light stripped out of it, which is why the sky is blue. So we need to find a little bit of an amber color, and exactly how saturated that amber color is really depends on the time of day and the time of year and what particulate matter's in the atmosphere. You'll notice the more saturated the color becomes, the more it feels like sunset or maybe autumn. But we don't need to go there. The main thing is that we have a fairly subtle blue color in our skylight and a fairly subtle amber color in our sunlight, so that when the colors mix back together, it should be pretty close to white. And additionally, our light intensity needs to be probably quite a bit higher. That's starting to feel like a nice blaring sunlight too. Don't be afraid to really turn your light intensity up for key lights, especially ones as bright as the sun. Now, one of the things I really want to do is go over to my render operator and turn on PBR, which is physically based rendering. So go to my properties tab. Oh, I am already in PBR. Okay, that's good. So we're getting some nice light bounces happening in here. Well, if we should be, let's just check our shading. No, we're not. The diffuse limit is at 0. So in order to actually have light bouncing, the diffuse limit, this is the number of diffuse light bounces, by the way. Diffuse limit needs to be above 0. So it needs to be 1, or, I prefer to go with even 2. And one of the nice things is going from 1 to 2 or even 3 doesn't really increase render times that significantly. That may sound a little bit crazy to you, but the trickery side effects is done is that instead of increasing the render time when you increase the number of bounces, what they've done is they've divided the number of samples among the number of bounces. So it won't be a lot slower, but it'll be a little noisier, and you'll have to reduce that noise in other ways. And we're going to start setting up our takes. So I'll pause this render. And first of all, we need to decide what kind of render passes that we want. Well, obviously we want the ground plane as a separate item. We want the shadow pass separately. We want the aircraft beauty separately. We probably want the, I'll just let this continue to resolve as we talk about this. We're going to want a reflection pass and probably a specular pass. We may want other passes, but we'll start with those. So the first question is, how do we go about getting just the ground pass out of here? It's pretty straightforward. Let's go to our take list. We see that we have only one take, the main take. That's the one we're in right now. And we want to add a take. So we're going to add a take with the main selected. And what that's going to do is going to make a new take that is a child of the main take. What a child take does is it inherits all the values from the take above it. So I could make a bunch of changes to this take and then give it a child, and the new child would inherit all of those from take 1 plus all of those from the main take. It's a good way of quickly setting up groups of render passes. I'm going to call this one ground. And now I need to make some changes to my nodes in order to make this be just the ground. So I'm going to go to my objects, where all my objects are. Now, here's a caveat. We are in the ground take now, we're not in the main take. So any changes that we make are not going to occur in the main take. Additionally, we're going to turn on something called auto takes. This can be quite dangerous because when you turn on auto takes, you're going to change parameters within these nodes. And if you think you're in the main take and you don't realize auto takes are on, you can really screw up your scene. So I strongly advise you to always be aware of what take you're in and whether or not you're in auto takes. Now there is one thing that's very helpful in knowing whether or not you're in auto takes, and that is when you turn it on, we'll go to one of the takes. When you turn it on, the parameters all get this kind of tan color. So that's your visual indicator that you have auto takes turned on. And that will only happen if you are not in the main take. If auto takes is off and you're not in the main take, all of the unchanged parameters will be grayed out. So those are the visual indicators for you to know that you're not in the main take and if auto takes are on. Be aware of those because seriously, you can really mess yourself up. Okay, so in our ground take, what we definitely want is only the ground. We don't want these other objects to be visible. So we can simply select these objects in this take with auto take turned on, and we can switch them off. Now you'll notice that when this rendered, we didn't see these things switch off. And here's the reason why. We are in a take called ground, and we're using the mantra ROP, and the mantra ROP is using the main take. So in order to get this to show up in our IPR, here's what we need to do. We'll pause this. We'll go over to out. We're going to add a new mantra node. We're going to actually name this one IPR. And we're going to add a new one, tab and render, to grab a mantra render node or mantra ROP. Drop it down. Now, you'll notice here it says render with take, and we'll also notice that these are all tan colored, which means we're in auto takes. Unless we're in the main take, we can't change the parameters of our mantra ROP. So we're going to go back to the main take, and we're going to say we want to render this ROP with the take ground. We're actually also going to rename this ROP ground. So now the name of the ROP coincides with the name of the take that we have selected within the ROP. It's really important to keep this naming the same, otherwise you're going to find yourself really confused when you have 20 of these in your scene. Now that we have a ROP that is using this take, we can go over to our IPR. I'm going to unpause it here, and we can switch the ROP to ground, and we'll see what the ground ROP renders now. And it renders just the ground by itself, exactly as we expected. Okay, next let's do a ground with the shadow. So we'll go back to our take list. We're in main. We're going to add another take. We're going to call it ground underscore shadow. And once again, we're going to have to create another ROP. Let's just copy and paste this one. Copy, paste. And we'll rename this one ground underscore shadow. And within it, I have to go back to main. Within it, we'll say render with take ground shadow. And we'll go to our IPR and switch it to ground shadow. Now we're going to render everything that's inside this ground shadow. And since it was taken straight off the main take and no changes have been made yet, this ground shadow take is currently exactly the same as main. And you can actually tell that no changes have been made because if you click on it, you can see that this list on the side is empty. If you click on a take and you see values here, you can tell exactly what items have been changed within the take. The list is right there. So what we're interested in doing this time for the ground shadow take is we're interested in keeping the shadow but making the geometry disappear. That's pretty straightforward. Simply go to our objects again. We're going to select all of the aircraft nodes once again. Turn on our auto takes. And we need to turn on phantom for all of these items. That means that the item itself will not render, but it will still ray trace. And let's see what that looks like. So there we go. We have our shadows cast. You can actually see the sky shadow here and the sunlight shadow here as well. Yeah, but the aircraft is not visible. So now we have a second pass ready to go in our outputs, and that's ground and ground shadow. Now let's do one of the aircraft by itself. Once again, we'll go back to our take list, go back to main. I'll just pause the IPR for a moment. Add a new take. Call it aircraft. Copy paste the ROP. And I want to go back into my main take here and turn off auto takes. I always turn off auto takes when I'm not using it, just kind of as a way of protecting myself against making a bad mistake. We're going to call this aircraft and render with take aircraft. Switch IPR to aircraft, unpause it, and once again it should look like the main take with everything in there because we haven't turned anything off yet. We'll go back to the aircraft take, turn auto takes on, and this time we just want to go to the objects and turn the ground plane off, the grid. So we'll take a look at that now. Now I'd probably suggest that if we're rendering this as a separate pass, we probably don't want the sky to be visible. And also, I made a mistake, we don't want light to be cast up from underneath from our skylight. Let me just double check that. We did clip it to the positive Y hemisphere, that's good. See, when we turn off, this is actually good, I can show you this. When you turn off clip to positive Y hemisphere, you can see how all this light is coming from beneath. When you turn it on, watch what happens. It gets darker underneath. So it's not actually casting light from below. But anyways, in this take, we want to turn off render light geometry. So there we have our fully illuminated aircraft as a separate pass. We can actually click on A for alpha and look at the alpha channel to make sure that it's cutting out properly and there's nothing else in the way there. C goes back to color. And now we have in our outputs ground, ground shadow, and aircraft. Now I'd like to get a reflection and a specularity pass out of this aircraft. So we'll start with the reflection. I might want to enhance that reflection a little bit. But I also don't want the sky or the ground in there, so I'm going to start from this take. So I can go to the current take aircraft. With it selected, I'll click add take, and you'll see that becomes a child of the aircraft take. I'm going to call this one aircraft underscore REFL, which means reflection. Copy and paste the render node, the ROP. And going back to main, going to look at the parameters of the ROP and switch it to render with take aircraft reflection. Now I can switch this to aircraft reflection. I have to, of course, rename this aircraft underscore ruffle. See how important it is to keep the names right. So now that's in here, aircraft ruffle. And then I simply need to go back into my aircraft reflection take, turn on auto takes, go to my material palette, or I can actually also go into the shop, which is the shader operators. So here's all the various shaders that are part of this aircraft. And I just want to get the reflection pass out of everything. So I'm going to select them all. And I want to keep reflect objects on everything. What I want to turn off is diffuse. So there goes the diffuse. I also want to turn off reflect lights, which is side effects way of saying specular highlights. They don't use the term specularity to refer to light highlights, at least in this context. It is used that way elsewhere in the software. But they're switching to reflect lights and reflect objects instead of specular highlight or specularity and reflection. And the reason they're doing that is because since there's so many physical materials and physical renderers and ways of rendering physically correctly nowadays, we're discovering that the term specularity, as in the context of CG rendering, it is in conflict with physical reality. And the physical reality is that specularity means smoothness. So something that's very smooth is highly specular, not necessarily something that is showing a bright light highlight. And CG artists have used the term specularity as it was coined for the Phong shader so very long ago, and people have used it to refer to light highlights ever since then, even though it's not really the correct terminology. So instead of saying specularity here, we're saying reflect lights, and instead of saying reflection, we're saying reflect objects. And I think that's a pretty intuitive and elegant way of going at it, because this terminology is in concert with physical reality and is also intuitive and easily understandable by new artists that are coming along to the software. So I want to turn off reflect lights, and that'll take away what we traditionally call our specular highlights, and that should leave me with only object reflections. Now here's an interesting thing. That actually didn't do what I was expecting it to do. I'm going to turn reflect lights back on, you'll see what I mean. It's reflecting the sky as well when I say reflect lights, and that's because the environment light has been set to show its geometry. And the environment, the whole sky, is just a light. So in order to turn off the specular highlight from just the sun, we're going to need to go to the objects and grab the sun and disable only its specular contribution. There we go. So now what we're receiving is object reflections, in other words, reflections of the aircraft onto itself, or areas where that reflection is occurring, and reflections of the skylight, but not direct reflections of the sunlight. And you may or may not want that in your scene. Actually, I think it looks kind of good, and that's probably what I want to be enhancing anyways. So I'm going to leave that in my reflection pass. So if we look at our ROPs now, we have the ground with a shadow. We have the aircraft RGB, it's basically the color pass, and we have an aircraft reflection pass. Okay, let's take a look at rendering these out, and we can also have a look at render dependencies. First of all, let's look at our where we're going to output our image. First thing is we need to get out of this take. You can see that it's a take by these light tan fields. So go back to the main, and we're going to turn off auto takes. So we want to make sure we're using the correct camera here. If not, we can select it from a list here if we have a different camera. We have the option of deciding by basically overriding what's in the scene and choosing which objects render candidate objects means, well, star means all objects, or we can create a list of objects. For example, if we only wanted to render, let's see here, if we only wanted to render the propeller and the rudder, propeller and rudder, we could accept the pattern, and now it's only going to render those two items. We can also force it to render tires, like say for example the tires are made phantom. We can force it to render them. And the same thing with forced, we can force an item to be a matte object, or we can force an object to be a phantom object. And we can also exclude objects. So these are basically ROP overrides for whatever may be in the scene. We'll just set it back to its default. And you can do the same thing with lights as well, solo light. So if you only want to render this ROP with a single light, you can force it to use just a single light. You can offer it the candidate lights, you can force lights, or you can exclude lights. And here's of course your headlight creation as well. In order to set your output, you need to go to your properties, and there's a lot in here, beginning with the output picture. And right now the output picture is going to the interactive preview. So we want to put our renders somewhere. I suggest we put them in hip renders. So hip is basically our project directory, and I built a renders directory in here. And we're going to call this file, since it's our ground, we're going to call it ground. And if we just call it ground.exr, ground.tga or TIF or whatever, and we're only rendering a single frame, that's just fine. But if we're doing a sequence of frames, we need to tell it that by going dot, for example, $F4. And what that says is that there's a frame number here, and it's padded to 4 numbers. So the first frame would come out as 0001. Or you could do, you could do $F3 if you wanted 001. And then dot, for example, EXR you might use. We can accept that. And then we can actually copy this. We can stick it in our other ROPs under properties output in place of the IP. And then of course we're going to want to go back and actually change the name. For example, this one is aircraft reflection, so instead of ground it needs to be aircraft underscore ruffle. You're of course welcome to name these whatever seems appropriate to you, or whatever your pipeline demands. And ground shadow. So these ROPs are all set up. We'll just double check. Ground is using the take ground. Ground shadow is writing out ground shadow, is using the right take. Same with aircraft. Same with aircraft reflection. So these ROPs are ready to render. Now if we wanted to render a sequence, we'd have to change the valid frame range here to render frame range, and then we put our range in 1 to 120 or whatever. In this case we're just going to render a single frame, so I'll just leave it at render any frame. And rather than rendering each of these one at a time and rendering them as straight ahead, I just simply have to click the render button on the ROP and then wait for it to finish, and then click this one and hit render, and then click this one and hit render, and then click this one and hit render. There's a better way, and it's something called render dependencies. One of the good things render dependencies is good for is exactly this thing. You have a whole bunch of ROPs. You want them all to render. Maybe you want them to render overnight. You don't want to have to get up every couple of hours and start a new one. So you just chain them together. And then what will happen is you go to the bottom guy in the chain, you hit the render button, and it's going to start at the top and do ground, then ground shadow, then aircraft, and aircraft reflection. It's going to render all 4 of those frames and put them in the output directory that was specified. So I'm going to click the render button here. You can see it's doing ground frame 1. So I'm going to pause here for a few minutes while these 4 frames render, and then when they're done, we'll be back. Okay, let's just take a quick look at the render passes that came out. So here's our color render, our ground with the shadow render, our ground by itself, and our reflection pass. And those passes can be used a number of different ways in comp. Typically, if you're doing a shadow, you would do just a shadow on a white, purely white plane, or you'd export it as a shadow buffer, a separate pass that comes straight out of the initial render rather than separating it into multiple renders. So creating takes and running multiple ROPs is one way to get render passes out of your scene so that they can be composited. But there's another way as well, and that's by using something called image planes, and you can assign multiple image planes into a single ROP. Now, an image plane, a lot of people will think of these just as buffers, export buffers. So let's take a look at that. So instead of having 1, 2, 3, 4 of these things, let's just delete these 3. This one we'll just name aircraft. And inside of it, instead of using a take, we're going to use the main take, which is the basic everything. So let's just check that out, take a render of it and have a look. So there it is. So you can see it's back to the full render with everything in it. Now if we want to start exporting channels out of this, for example spec channel, reflection channel, or diffuse lighting channel, or color channel, or whatever, there's a really unbelievably easy way to do this, and you find it by going into properties on the output tab. If you scroll down at the bottom, you'll see this thing where it says extra image planes 0, and when they say image planes, they mean another channel that's taken out of this single render. So let's just add 1 and take a look at it. So I'll just type 1 in there and click the plus button, and it will add, here I better pause this render, it will add these new parameters, and they'll start by saying a vex variable. And what they mean by this vex variable is what layer of the render, what channel do you want to be exported for this image plane, for this buffer. If you click on this little down arrow, you get a list of all the available channels. And I'm actually going to tear off a duplicate pane so that we can so that I can show you the list of vex variables. And by vex variable, they mean what image channel. So here they are. There's color, opacity, alpha, position, Z depth, normal, a whole bunch of diagnostics, direct diffuse, specular, refract volume, emission, blah 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 blah. It even goes way off your screen. It's quite a long list. It goes down to a whole bunch of really obscure and strange ones. Combined reflect, combined refract, combined specular, blah blah blah. So you can get the idea that if you want to just do color, you just drop CF in, and then you want to give the channel a name, so we'll call it cull for color, or you can call it RGB or whatever. People have different ideas about what that should be called. Now if we're rendering an OpenEXR file format, a floating point EXR file format, or a mantra.pic file, then we don't have to do anything else. This channel will be saved in the same file along with the full render, and then it can be split out in compositing and used for compositing later. On the other hand, we also have the option of saving this image plane out as a separate file all by itself, simply by clicking different file and then selecting a file location for it. So we might go into our renders and might make a new folder, call this our color folder, and we might call this aircraft.cull.$f4. whatever file format it's going to be. Let's say Targa for this. And you can add as many of these image planes as you want. And for each one, you can put in a different channel. So you can have multiple render buffers coming out of a single render. This is obviously better than splitting out into multiple different renders, because it means you only have to deal with the render time of one single render pass rather than multiple different render passes. You can't do everything this way. You are limited, unless you're coding shaders yourself, you are limited to the channels that are in this list. And then if you want to make different objects on and off, different lights on and off for different passes, then you're simply talking about doing that with takes and rendering them with different ROPs. And then of course you can chain them together and have render dependencies if you wish. But this is super powerful. Now there's one more thing that's really super cool about these extra image planes, and that is this option, and that is to export variable for each light. So now I'm going to get a color channel for every single light that's in the scene. I currently have two lights. I have a skylight and a sunlight. So it's going to export the color for each one of those. Let's add another image plane. And this time, let's find it here. Let's pick, let's find an interesting one here. Let's pick Direct Reflect for this one, and we'll call it Ruffle. That'll be the name of the channel. Give it a different file also. I'll go up and make a new folder called REFL. And I'll go in there and I'll call these ones aircraft.refl.f4.tga. Now I can go ahead and, and I'm also going to set this one to export one for each light. So I can go ahead and launch a render and render these, or I probably want to test it out first. Now we've talked about using the IPR, and we've talked about using the render region, which is simply clicking on the little render region button, selecting an area to render through. And of course there's another way to render, and that is to render out to mplay, which is the viewer. I'll just let this resolve. And you render into the mplay viewer by clicking this little spool of film here. And when you click it, you'll get an option. The option is, it's asking you which ROP you want to use to render this. So we have the Mantra IPR and the aircraft one in there. We're going to use aircraft. And that's going to render out into mplay now. So our render's done, and I'll just make it a little smaller here so we can see it. So here we have our color render, and then there's the we created two image planes, one for color and one for reflection, and you'll see that they've appended the names of the lights, skylight and sun. So we have one render for each one. So if we look at the skylight color compared to the skylight reflection, we can see that we have the skylight in both, but color in one and reflection in the other. If we look at the sun reflection, on the other hand, you can see it's quite different. It's tighter, it's a smaller light source, it's more intense and more direct. So cutting stuff into image planes is a super fast way of getting all your render buffers out, and the real beauty of it is that it doesn't take additional renders. It all comes out of one render time, so you get those extra image planes for free. So there's one of many, but this one feature called a parameter spreadsheet can be incredibly useful for setting up your scenes properly, and it becomes especially handy when you have, for example, a whole bunch of render output nodes. So we have ground, ground shadow, aircraft, and aircraft reflection, and you notice we were going through each one and checking which take it was rendered in. Let me just go back to the main take so we can see it. So aircraft reflection is rendered with this take. We go over to this one to check its take, and it could be in a different tab, so a really quick way to check these all against each other is to use a parameter spreadsheet. If you just go under Windows here, you can find the parameter spreadsheet. It comes up, and it it's not displaying anything right now. We need to put a mask in here and a parameter mask. So we could say asterisk for everything, and we could say parm mask asterisk for everything. And what that's going to give us is every single operator in the entire scene, and there's a lot of them, and then also every single parameter in the entire scene across here. And that is interesting, but not very helpful. Let me just embiggen this a little bit so we can take a closer look at it. I coined the Bomar term embiggen. So you can see there's a lot of parameters, and many of the parameters don't even apply to many of the operators. So there's a lot of wasted space in here. So in our case, we want to look at, for example, all the render operators. So we'll just click on out, and that takes us down to out. And then we want to just look at what take. So we need to actually select the ROPs that we need. We can't just say out. We need to select the specific ROPs, or we need to say out slash asterisk, which will essentially do the same thing. And that now has, because we have in the parameter mask, we have star, that's showing us all the parameters. And that's kind of manageable, but it's still quite a lot. In this particular case, we only want to see what take is being used. So if we just look down this list, we can see all the operator labels and the operator names. And if we just look down here for a minute, we can find the takes. And there it is, render with take. And the parameter name is take. So we'll simply type take in here. And now that will show us only the takes. And we can actually just squash that over. And we can see what take each ROP is using. And that's not all. When you see this kind of a field here, this is actually a drop-down list. So we could actually change our takes right here if we wanted to change them all to main, which we don't, so I'll just switch them back. This one was aircraft. This is ground shadow. And this one is ground. So you can see how that could be useful. As another example, there's a lot of quality settings inside their render operators, such as pixel samples and min and max rays and things like that. So we could actually stack all those into here and compare them against each other, because if we're doing a bunch of render passes, in general, we want to make sure their qualities are all the same so that they'll line up properly in compositing. So if, for example, we can look here and we can see here's min ray samples and here's max ray samples, and they have their appropriate names, but they start with the VM underscore max ray samples. So let's remove take, and we'll put in VM underscore min ray samples, and then we'll just leave a space and put VM underscore max ray samples. And we also might want our pixel samples. And right here we have VM samples X and VM samples Y, because our pixel samples are X by Y. So we can also include VM samples X space VM underscore samples Y. Now that shows us the parameters we want. I'm just going to rearrange them so they're a little bit easier to see. Oh, and I see there's only 3 columns here because I've made a typo here. Min ray sample is supposed to have an S on the end, so it's not recognizing that. There, we've got all 4 now. So min and max and X and Y for our samples. So we can simply use this to look at these and confirm that they're correct or as we expect them to be, or we can change them right here. If you want to select rows, you click on the associated operator, and if you want to select columns, you click on the associated parameter. So for example, if I wanted to change the min rays of all of these ROPs, I can click on the column, click directly on the parameter, and if I change one of these, they'll all change. So all the ones that are currently selected are changed. can change my max ray samples to whatever, 12. I can change my, and I can shift click to select multiple columns, of course. And I would do this in this case because normally the X and Y samples are the same. So I might say 8 by 8. And that's a very fast way to change multiple parameters inside multiple operators without having to click through each one, and then you're not sure if you've got them all, and it can lead to a big mess. This is a very fast and certain way of lining them all up together and quickly ensuring that they all have the values that you expect of them. So the parameter spreadsheet can be incredibly useful and becomes more and more useful as your scene becomes more complex, of course. Okay, there is yet another way other than takes to sort out different items into different ROPs. You don't actually need to use takes for everything. And this is called bundles. And all a bundle is a group of items. It could be a group of geometry or a group of lights or whatever. In this case, I'm going to show it to you using lights to begin with. So what I've done is I've put 9 lights into our little biplane scene here. Just 3 of each color, red, green, and blue, just for demonstration purposes. And I'm going to create 3 ROPs, and we're going to assign the lights to them by bundles. So the first thing we need to do is group our lights together by their color codes. And we need to make 3 bundles. So we go to Windows, Bundle List, and you can see there are no bundles. So we're going to create a new bundle. We're going to name it Green Lights. And I'll make another one. We'll call this one Blue Lights. And we'll call this one Red Lights. So in order to assign, all we need to do is grab our lights, make sure we're on the correct bundle, and you'll see up here this one says add selected nodes to bundle. So we've selected the bundle we want, we've selected the nodes we want to add to it, we click this, and now that's what's inside the bundle. See, there's nothing inside blue lights, there's nothing inside red lights, and you can see that the color has changed to indicate that there's something inside of the bundle. We'll select the blue lights bundle. We'll go over here and select the blue light nodes, and these are just point lights. Add those to that bundle. Go to the red lights. Grab the red light nodes and add them. So now we have a bundle of the blue lights, a bundle of the green lights, a bundle of the red lights. If we look at a normal render in our render view, so the main normal render has all 9 of those lights in there. What we want to do is create a ROP, each with only 1 bundle in there. So let's go over into our outputs, and we'll create, this is our main render node that we're using right now. I'll just delete these 3, and we'll make a new one. So tab, render, add a new mantra node. We want it to be using the current take, that's correct. Under objects, we have candidate objects, so we want to render all the objects in the scene. And for candidate lights, in this one, we're going to, well, let's make this one green light. And we only want to render the bundle of green lights. So in order to specify a bundle in here, you simply put an @ sign and then the name of the bundles. Green lights. Green lights, I believe that's what it was. And there it is. I'm just going to double check to make sure I got the name of that bundle right. Green lights, yeah, that's right. So we're going to copy this, put 2 more down, and rename this one to red lights, rename this one to blue lights, and of course in our red lights, our candidate lights are going to be at red lights, and our candidate lights for our blue lights ROP will be blue lights, at blue lights, which indicates the blue lights bundle. So now when we go back to our IPR and we select our green lights ROP, here's what we get. So this ROP is rendering only with the lights that were in that bundle. And let's switch to the red light ROP. So you see we didn't do this with takes. We don't need takes to make these selections. And in fact, we could just, if we look at the names of these lights, we could do it by just typing in the names of the lights as well. We don't need to use bundles. And this is a fairly simplistic example, but you can imagine if you have a scene with tons of lights. Say you have a cityscape scene and you have street lights, and you may have neon lights, you may have car headlights, you may have window lights from nearby architecture. You may have all of these different layers that you want, and there's tons and tons of them. So rather than typing in green light 1, and green light 2, you just assign them all to a bundle, and then you can quickly assign them into ROPs and render that way. So bundles can be extremely useful. You can also obviously use them for geometry as well, and we'll look at that in just a second. But first, let's just look at this and look at a different way we could do candidate lights. So we're in red, so let's look at the red one here. Let's just delete that. So instead of using all the lights, let's instead delete that and select the lights from a list. So here's our list, and we could actually, since we're in red lights, we could actually just go ahead and multi-select, say accept pattern, and that'll put the names of those lights in there. Or alternately, we could type them in. So we could, for example, go red light, green light, blue light, and get the first one of each. So one of each color is now being used. So this is what they mean when they're talking about candidate lights. If you wanted it to be a solo light instead, that gives you just a single light. So if you have tons of lights, this is actually a good diagnostic tool. Say you have tons of lights in your scene and you want to see what just one light is doing, simply type that light or select it from a list into the solo light, and you'll get to see just what it's doing alone in the scene. It's very useful for diagnosis of your lighting. You can also exclude a light. And you can also force a light. So for example, if let's go back here and go to objects, to the first red light here, and let's disable that light, and then we'll go back into the output and we will force red light. So even though it's been disabled in the light itself, we can force it to be used here. So we can override the parameter in the light itself even. Now, a fair warning, this can be quite confusing. If you may be going around disabling lights and wondering why they're not turning off in your render, and this would be why if you've put them into forced lights. So these are all very useful, and you can apply exactly the same logic to objects. Candidate objects, we can force certain objects even if they're phantom. We can force objects to become matte objects, and what I mean by that is, let's just look at an object here, for example. Let's look at the fuselage, or no, let's look at this lower wing here because we can see it quite well. So let me find that object. Upper wing, lower wing. Here it is. Here's the lower wing. We can tell this object to render as a matte object, and some people call that a holdout object. It's an object that acts as matte inside a normal render. So if I turn on matte shading for the wing, you can see that it turns black. And if I look in the alpha channel, you can see that it shows up not visible in the alpha channel. So it's allowing us to cut out other bits that are in front of it. So that's what matte shading is. And if matte shading isn't turned on there, we can go to our output and we can force an object to become phantom right here, even if it isn't set that way in the object properties, in the object parameters. Where's that lower wing here? lower wing. So we'll accept that pattern, and now we see nothing because I did forced phantom instead of forced matte. So I'll just cut that and drop that into forced matte. There we go. Now we see it turn up as a matte. So same idea. You can do exactly the same thing with the geometry as you have done with the lights in terms of candidate, forced matte, forced phantom, exclude objects, and so forth. I can go back to my color, and I can I'll cut this out, and I will exclude the lower wing this time. So no matter what it says on the object itself, it will be excluded from the render because I have excluded it here in the ROP, so it won't be able to render. I can also go ahead and bundle a bunch of objects. I'll just delete that so that everything should be rendering again. And I'll go back into my objects. And I'm going to open up the bundle list again. I'm going to create myself a new smart bundle. And I'm going to call this one Wings. And obviously what I'm going to put into it is wings. So there's my lower wing and my upper wing, and I also would like my ailerons to go along with that because they're part of the wings as well. And I'm going to add those to the current bundle, all of those items, the 4 ailerons and the wings. That hasn't changed anything in my render yet because I haven't done anything with the bundle. But when I go back to my ROP, and we're looking in the red lights ROP right now, actually, let's go back to the aircraft ROP. That one has all 9 lights enabled. And inside this aircraft ROP, once again under objects, we can exclude individual objects or bundles. So if we look in our bundle list, we'll remember that the bundle we just created is called Wings. So we will exclude at Wings. And that will exclude both the upper and the lower wing and all 4 ailerons. And we'll see that. There we go. So that works. Now there's another way to create bundles. Also, you can create it from an object list. So for example, right here I could just grab all 4 ailerons, and there's a create switch here and a bundle name here, so I could call this ailerons. As soon as I hit create, there's a new bundle called ailerons. I could put all the struts together. I wonder if that's all of them. Yeah, and I could make a bundle. I create a bundle called struts. And now, if I want to exclude, I can exclude the struts at struts. I can also exclude the wings at wings. If I decide rather than just excluding these objects, I want them to be invisible but cast shadows, I can simply cut this and put it in forced phantom instead. So there they are. They're invisible, but they're still casting shadows. So you can see, I mean, just this is a very simplified example, but you can start to imagine with lights and with geometry how many different permutations there are here and what the possibilities are. When you're working on a large project and you have groups of lights, groups of geometry, creating bundles is absolutely crucial to your workflow. It'll massively speed you up. You won't be constantly selecting groups. And basically that's what bundles are for, is to prevent you from having to constantly select convoluted groups of items. So I hope you see the value of that. I certainly enjoy the bundles. And that's it for the section on bundles. So that about ties it up for this introduction to rendering. In this video we've taken a brief overview at ROPS. We've looked at how to use takes in your renders and render dependencies, how to use image planes, how to use the parameter spreadsheet, and how to use the very useful feature bundles. I hope this has been useful to you. If there are any areas you think that are missing that could use clarification, please do feel free to contact us at contact@cgmasters.com, and we'll improve things. Thanks so much for all the people who've given their support and feedback so far. We think this is a great way to continually develop and improve our work. And we'll see you in the next video.